Okay, we're going to talk a little bit here about equivalent fractions, some ways we've already talked about, ways to find them, and a new way that we can find equivalent fractions. So from what we've done before, we know that this fraction over here represents 1 out of 2 parts, so this is 1/2. This fraction is also 1/2, but I can come up with an equivalent fraction by adding a partition to the center. Now notice I did not shade any more yellow. The amount of yellow stayed the same, so now it's 2 out of 4. So the new fraction is 2/4. But I know that 1/2 and 2/4 are equivalent fractions because the amount that's shaded, or the amount that was yellow, didn't ever change. So let's take a look here. Here's our fractions 1/2 and 2/4. And this fraction number line has 1/2 represented on it. And we've taken the same number line but added a couple more partitions to make it 2/4. You can see this point is halfway down the number line, and this point is halfway down the number line, or we could say 2/4. Looking here, we're going to find 2 ways to make an equivalent fraction. So let's look at the original fractions for both the picture and the number line. Here I can see we have 1, 2 shaded out of 3 total. So the original fraction is 2/3. And we have 1, 2 segments out of 3. So this must be 0/3. This is 1/3, 2/3, and 3/3. But the fraction represented on both is 2/3 and 2/3. So we're going to partition our other model to come up with a new fraction. One thing I need to make sure of is that each piece or each part of the whole is still the same size as the rest. These are pretty close to all being the same size. I can see my new fraction is 4 out of 6. Now one thing to pay attention to is how many pieces did each part get split up into. So this was 1 piece and it got split into 2 pieces. So here's 1 segment and I can split it into 2. This segment will be split into, this segment will be split into. And hopefully I should have 6 segments or 6 spaces. 1, 2, 3, 4, 5, 6. So this should be 0/6, this is 2/6, this is 4/6, and here we have 6/6. So the point is at the same spot on each number line. On this number line it's 2/3, and on this number line it's 4/6. But the distance that it was from the beginning didn't change, just the number we used to represent it. That's an equivalent fraction shown on a number line. Let's look at another way we can do it. Again, I'm starting with 2/3 for both. Now, I could split it here, but the problem is this section is much larger than this section. I want to make sure all pieces are the same size. So maybe instead, I can split it like this and try and keep them a little more even. Looks like I have 1, 2, 3, 4, 5, 6 shaded out of 7, 8, 9 total, 6/9. Each section, each one part got split into 3. So each section on my number line should be split into 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. This should be 0/9, 1, 2, 3, 3/9, 4, 5, 6, 6/9, 7, 8, 9. I always want to end on a whole. So just paying attention here that I have 6/9 shaded on my picture, and 6/9 is the point on my number line. Those are equivalent fractions. Here's a new set of fractions, a new set of original fractions. This fraction is 1 shaded out of 4 total, 1/4. Hopefully my number line is the same thing. Looks like our point is on 1 out of 2, 3, 4. So this should be 0/4, 1/4, 2/4, 3/4, and 4/4. I started at 0. I ended at 1 whole or 4/4. I have 1/4 shaded here and 1/4 represented on my number line. Now I'm going to change the fraction I have over here. One way I could do it is to split each section in 2. So now my new fraction is 1/2. out of 8, or 2/8. I'll do the same thing on my number line, split each in 2. So I have 1, 2, 3, 4, 5, 6, 7, 8 segments. So my number line starts at 0/8. I'll skip because I'm a little crowded. Go on to 2/8, 4/8, skip, 6/8, and 8/8. And I'll pay attention to the fact that my number line and my picture are both showing 2/8 for each representation. Let's go ahead and look at one more. Now last time I just split each one in half. I'll see if I can come up with something a little different. Maybe I can split each one into 4 sections and try and keep all of my parts or pieces the same size. Same size as each other. So it's not perfect, but it's pretty close. So I'm going to count 1, 2, 3, 4, shaded as my numerator, out of 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 4/16. So each piece got split into 4, so I'll do the same thing on my number line. This segment will be split into 4 sections, 1, 2, 3, 4. Same thing here, here, and here. So I'll count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I think I have 0/16. Maybe we'll do every 2. 2/16, 4/16, 6/16, 8, 10, 12, 14, and 16/16, or 1 whole. Make sure to take notice of the fact that we have 4/16 shaded and 4/16 on our number line. They both started out as 1/4, but we've created equivalent fractions of 4/16. One more way I can check is just to look at the numbers, and I'll go ahead and write my original fraction, which is 1/4. My equivalent fraction is 4/16, and I'll ask myself, can I perform the same operation for the numerators and the denominators? And if I get the same number for both, that means they're equivalent. 1 times blank is 4. Well, I think 1 times 4 is 4, and 4 times 4 is 16. So since these multipliers are equal, I know that these fractions are equivalent. Hopefully that gives you a little bit of a better idea on how to create equivalent fractions with pictures and models, and also with a number line.